Hello, ladies and gentlemen. Miss Lawhart, Chapter 11, LT6. I can correctly graph a sine or cosine cycle of these wonderful trig functions. So we have to remember that as we graph a sine graph or a cosine graph, our x-axis represents degree measurement and radian measurement. Okay, most of my graphing will be in radian because you should graph in radians. If you need to switch to degrees to find your intervals, that's up to you. So let's talk about these graphs. Okay, so remember the sine graph is when we're talking about sine, we're talking about the y value. Here's your unit circle from last week. We're talking about the y value. So as we go forth, here is a sine graph. So remember, the x-axis is your degree measurement. Okay, this is actually in radians on this picture right here. But you will see your graph, it's going to generate it as we go around the unit circle. So remember, at 0 degrees, the y value is 0. So that's why 0, 0 is our first coordinate point. So then as we go up to 90 degrees, our y value increases until we get to that high point right there. What's the y value? Positive 1. So our graph has an increasing first part, then going from quadrant 1 to quadrant 2, what does the y do? The y decreases back down to 0. So when we are at that 180 mark, sorry, a little bit off, we are at the y value is back to 0. So now when we go down to 3 pi over 2 or 270 degrees, what's the y value? We're at negative 1. And then when we complete our circle, we're going back to 0 because the y value is 0. So that creates our sine graph. Okay, it's a nice little wave function, and all it does is continue to sneak down the x-axis in the same graph. It goes up to 1, down to 0, da 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 da. Okay, it's their sine. Now let's talk about the cosine. Remember, the cosine, when we're talking about cosine, we're talking about the x value. Okay, so when you think about that very first quadrant point, okay, what is the x value at 0 degrees? The x value is positive 1. So your graph is going to start up here. What happens as we go to 90 degrees, our x value actually goes down to 0. So at 90 degrees, what's the x value? 0 degrees, so there's our coordinate point. When we go to 180, our x value goes down to negative 1. Boom. Okay, so then as we go back to 270, 3 pi over 2 degrees, we are at back to 0, and then our x value increases back up to 1. So there, my friends, is your cosine graph. Okay, it looks exactly like your sine graph, except it starts up at 1 and goes back to 0 and then completes the cycle. Okay, so that's kind of the generating of the graph. Let's get more into it. There are some words going on. So I will say that in a cosine or sine graph, however it is, this midline right here is called the midline. Okay, usually a sine starts at your midline, cosine does not. This piece here is called your amplitude. You know how high your crest rises or how low your crest falls. The amplitude is the absolute value between these two values. Your period is how long it takes one cycle to complete. And I have definitions right here. So amplitude is the distance the function rises and falls above its midline. How do we figure out what an amplitude is for which graph? You just look at the coefficient in front. So for this first graph right here, cosine graph, our amplitude is 1, so you can see your high point is positive 1, your low point is negative 1. Here, this cosine, the amplitude is 3, my high point is positive 3, my low point is negative 3. 1/2, positive 1/2 is my high point, negative 1/2 is my low point. So you get your amplitude from the coefficient in front of it. If you're dealing with a word problem and you want to find your amplitude, it's the difference between your max and your min divided by 2. So there's amplitude. Frequency is the number of curves into pi. It's known as the v value. So as you see in here, this is your frequency, this v value in here. So for this equation right here, my frequency is 3. What that means is in 2 pi, so you can see 2 pi is here. How many complete cycles do I see? Well, there's 1, there's 2, there's 3. So the frequency tells you the number of curves in 2 pi, the number of curves in a circle, okay? The number of curves in 2 pi. So this guy right here, 1/3, my frequency is 1/3. When I go to 2 pi, I'm right here. You can see you only see 1/3 of that graph. Okay, the finish point is right here for this one, but I only see for 2 pi, I only see 1/3 of the graph. So that's what the frequency. The frequency is just to help you find what a period is. So how long does it take one cycle? Okay, so your period, to figure that out, you take 2 pi and divide it by your frequency. You take 2 pi and divide it by your frequency. So 2 pi over b. 2 pi over b. So for this guy right here, 2 cosine 2 of theta, how long is it one complete cycle? I can look at the graph and see that it completes its cycle. So it starts here, it ends here. So it's going to be pi. So in mathematically, you do 2 pi over the frequency. 2 pi over 2 gets you pi. And that tells you your period. This guy here, I can see it on my graph that to complete one cycle, I'm at 8 pi. In order to find that out mathematically, you take 2 pi divided by its frequency. So here's 2 pi divided by a fourth. It comes out 8 pi. So you can see that the period for this one is 8 pi. All right. So steps to graph this, my advice, you define your A, your F, your P, your amplitude, your frequency, your period. Your amplitude values, once you see what your amplitude is, that gives you your high point and your low point for your y-axis. All right, now this is going to get tricky. Divide your period by 4. So you need to figure out your period, and that's going to go right here. Then you have to divide it into 4 to see how much these intervals are going up by. Once you divide by 4, you should be able to add these values to get back to here. You just have to correctly identify your intervals where your critical points are happening. Once you have your intervals labeled, then you can use your critical points. Remember that sine starts at 0, it goes up, back down to 0, -1, 0. Depending on your amplitude, these values might change. Cosine always starts off at 1 and then goes down to 0, and then so on and so forth. So those are your critical points. If you need to pause this slide, please go ahead. I know there's a lot of information coming at you right now. All right. So let's do an example together. Let's do 2 examples. So first identify your A, your F, your P. So for this one, my A is 4. Okay, getting that from right there. So I do +4, -4. Frequency, I pull that from the theta, so that's going to be 1/2 right there. To figure out what my period is, I do 2 pi divided by 1/2. That's going to give me 4 pi. So then on my x-axis, I create 4 intervals. Same space. Sorry that they're a little off on this. My period goes here. I divide it by 4. So 4 pi divided by 4 is going to give me a pi right here. So then if I keep increasing by pi, this will be 2 pi, this will be 3 pi, and that'll be 4 pi. So now that my intervals are set, my amplitude is set, now I can use my critical points. Sine starts at 0, so I'm going to start my first point there. It goes up to +4, goes back down to 0, goes down to -4, and goes back down. And then boom, connect your dots with a nice curvature of a line. Hopefully they go through your points. And there you go. Now, if they wanted to see 2 curves, you just keep this going. If you wanted to go in that direction, you can go back in the other direction of -4 pi and have the same cycle. It just repeats itself. All right, another equation. Here's a cosine one. So again, x and y axis, amplitude would be 2. So here we go with my amplitude of +2 and -2. Frequency is 3 according to this. 2 pi divided by 3 is my period. Okay, 2 pi over b, so 2 pi over 3 is 2 pi over 3 right there. Now, this is going to get crazy with fraction work. You have to divide 2 pi over 3 by 4 to cut it into its intervals. Again, you can use your calculator, just don't put the pi in. Just do 2/3 divided by 4. It's going to pop out pi over 6, or 1 over 6. And then just stick a pi with it. So we're cutting the region of 2 pi over 3 into fourths. So now I have pi over 6. Pi over 6, another pi over 6 is going to be 2 pi over 6, which equates to pi over 3 when you simplify it. We're going to end up getting pi over 3 over pi over 6. Here's the fraction work. So then my next interval would have been pi over 2 for right here. If I add another 6, I'll be back at my interval. Okay, so there's all the fraction work in correctly cutting my period into fourths and labeling it. Now we have cosine, so cosine starts up. Boom, 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 boom. Connect your dots. Okay. And guys, I know this is a lot of fraction work right here, but this is just me showing you like the math behind it. Again, just use your calculator if you need to. I was just splitting your period into fourths and then correctly identifying what that interval would be. Okay. You try. Here we go. Go ahead and try these 2 questions. Pause me and then push play to see if you got them right. All right, here we go. First question, we got an amplitude of 3, so your y-axis should be +3, -3. Frequency is 4. 2 pi over 4 means my period is pi over 2, so that's going to pop out over here. Dividing that by 4, I end up with having to go by eighths, 1/8. So pi over 8 for your first one. If you add pi over 8 and pi over 8, you get 2 pi over 8, which is pi over 4. So here we go. Here's all the fraction work for me coming up with my intervals if you need to pause. But your correct interval should be pi over 8, pi over 4, 3 pi over 8, and pi over 2. This is a sine graph, so then your critical points should look like that, and your curve should be around, looks like that. Okay. The next one is a cosine graph, same amplitude as the one before. Way to stretch it out, Miss Heart. Amplitude says we got 3, -3. Frequency is 1/3. 2 pi divided by 3 is 6 pi. So then that becomes 6 pi. 6 pi divided by 4 is going to be 3 pi over 2. So each of this is going up by 3 pi over 2. So 3 pi over 2 plus 3 pi over 2 is going to get you 6 pi over 2, which is 3 pi. And then a 6 pi over 2 over another 3 pi over 2 gets you to 9 pi over 2 over here. So there's your correct interval. Cosine starts up, boom, boom, boom. And there's your curve. Okay. Those of you that are doing the Schoology worksheet, you just have to do 5 correct ones. I gave you a worksheet with a bunch of examples, so try 5 of them and send them to me. Those of you for Delta Math, I just want to give you some advice on it. So this question will look like this. My advice here, you have to put your amplitude, go by ones, okay? Here, put in your period. So 2 pi over 6 gets you pi over 3. So then you hit enter and this little dot will pop out over here. I created an interval of, so you need an interval of 4 increments. I went by 2s. So if you see 2, 4, 6, 8, so then I put my period there. So then you just identify where your critical points go. You don't have to label that x-axis with everything because it'll do it for you, but it's still a little bit of work. So then you might need to, try a few to get it right. You have to complete 5 correct. There's your video for the day. Have a great one.